So before we start lesson 4, this is a review of lesson 3. And first thing I wanted to ask you, what's the equation for torque? Okay, pause the video, write it down. Hopefully you remember. Okay, torque is equals to force times distance. Did you write that out yourself? Did you have to wait for me? Okay, I hope you remember it. Okay, the next question is, what's the unit for torque? Okay, write it down. I want to say give you a thumbs up if you got it. Okay, so thumbs up. Okay, so and then hopefully you remember from before, force is in Newton and distance is in meters. So if they didn't give it to you in meters, make sure you convert it to meters before you throw it into the equation. Okay, so the question asks, calculate the torque. So that's my unknown. If the force is 18 newtons and is 1.1 meters from the hinge. Okay, so the distance are always measured from wherever you're pushing to the fulcrum. So hinges is the fulcrum. So that means in this question, they gave me the force is 18 and they give me the distance is 1.1 meters. And I'm looking for the torque. Torque is force times the distance. So 18 meters times 1.1. 18 newtons times 1.1. So that gives me 19.8. Make sure you write your unit. A lot of you don't write your unit down. Okay? So that's from yesterday, just how to calculate torque. Today is an extension to that. Okay? It's a new law that is called the law of lever. And we're assuming, like we're seeing a lot of elephants and different things balancing on a lever. So basically, the law of lever applies when it is in static, okay? Meaning the thing is balanced. You're not moving anymore, okay? So a lever is in a static, is not moving in any direction and is not rotating anymore. So not moving in any direction is not rotating. So meaning the lever is balanced on both sides. And in order for that to happen, you need the effort torque and the load torque to be the same. Okay, we know how to calculate torque. Okay, torque is force times distance. We already talked about that. So to find the effort torque is the part that you're pushing down, right? The one that you're working. Okay, the load torque is whatever you're trying to lift up, right? So whatever the piece of rock or whatever heavy object you're trying to move. So the load torque is FL times DL. And the law of lever basically tells you the torque for the effort have to equals to the torque for the load. So basically, we are combining these two equations together and make them the same, okay? So all I did is plugged in TE is FEDE, and then TL is FLDL. We already sort of did it yesterday when I was trying to introduce you with the lesson. Okay, so combining them together, this is your new equation for this unit. This is the second equation, and you need to know how to rearrange the equation to get things on its own, and we will talk about that. Okay, all right. So the most complicated thing is you need to figure out which one is your distance, and it's always measured from the fulcrum. All right, so let's take a look at this. This is your effort. Okay, effort is over at this side, right? They tell you FE. So this is the person pushing down, and they're trying to lift this weight. So this is your FL. This is your load. Okay, load is 128 newtons. So they already gave you the force. Okay, and if this is the load, then this distance from the fulcrum will be distance of the load. If effort is over on the right hand side, 2.2 will be the distance of the effort. So you match the words with the side that they're on. And the key thing is, it's always measured from the fulcrum. First class lever is easy, is wherever that turning point is. Sometimes they trick you when it's like class 2 or class 3. You have to be careful the actual distance from the effort to the fulcrum. All right, so let's write out what we have. I know FL is 128. I know DL is 0.80. I know DE is 2.2 meters. I am looking for FE. So write out your equation. So go back to here, right? FEDE equals FLDL. So FE dE is equals to FL dL. So always remember, you start off with the equation first. That's 1 mark, okay? All right, so now let's take a look. FE is what I'm looking for. So I'm not subbing anything in for FE, so I'm going to write FE the same way. DE, take a look at DE is 2.2, so I'm going to put it in a bracket. 2.2 equals FL. FL is 128. Put it in a bracket. DL is 0.8, so 0.80, okay? Now I'm going to, first of all, multiply out everything that's on the right-hand side. So 128 times 0.8, that gives me 102.4. It's equals to FE times 2.2. And then to get FE on its own, I'm going to have to divide both sides by 2.2. Okay, so this 2.2 and 2.2 is gone, so I'm left with FE. I take my 102.4, I divide it by 2.2, so I get 46.5. The unit for a force is Newton. So you get 1 mark, 2 mark, and 3 marks for doing this question. Okay, number 2. A camper wants to mount a trailer on the blocks for the winter. One corner of the trailer is lifted by applying an effort force using a 3 meters steel bar. Okay, they're being really tricky here. Okay, they gave you the entire board being 3 meters. The trailer has a force of 180. So they already drew the picture for you. The trailer has a force of 180. This is your FL, right? And it's 1,800 newtons. And it is 0.45 from the fulcrum. So they tell you from the fulcrum, measuring to the load. So we okay that this is your DL, distance of the load, is equal to 0.45 meters. They want you to find what is the magnitude of the force required. So they want you to find effort force. Okay, so let's write out. I want to find FE. And from the information, I am told that FL is 1800 Newton. And they told me that the DL is 0.45 meters. Looks like I still need something. So sometimes if you're not sure, write out the equation again. Okay, you can write them out, right? So I'm just going to look at here. This is the equation. FEDE equals FLDL. Okay, all right, so let's see. I have FL. I am missing DE. Do you see that? I am missing the distance of E. It's not 3 meters. Sometimes people just look at the question and just plug in the numbers that they see. But it's not 3 meters. Be careful for me to figure out what is DE. Do you see I have to subtract the 0.45 from 3? So 3 minus 0.45. So the actual distance is 2.55. I find sometimes drawing pictures help. Alright, so now that I have everything I need, I'm going to start writing them out. So FE is my FE. I don't know what it is, so I'm just going to copy this out. DE is 2.55. So I'm going to write 2.55 here. Equals to FL. FL is 1800. And then times DL, which is 0.45. Multiply out the right-hand side first. So 1800 times 0.45 is equals to 810. And it equals to FE times 2.55. Do you recognize the repetitiveness of this? It's the same thing, right? The one that I have the 2 number, I would multiply them out first and then divide it by the 2.55, whatever the number that's on the other side. Okay, so when I do that, these two cancel. I'm left with Fe equals to 810 divided by 2.55. So 318 Newton is like 317.647. So I just rounded up to the newtons, to the nearest